Hello everyone, Mr. White here with a little trick, the baking soda and vinegar makes a mess trick. You've done this one before, probably in your kitchen, or maybe when you were in elementary school, when you made a volcano. You know what happens when you put baking soda and vinegar together. It makes fizz, it makes a big mess. Well, here in chemistry class, we're going to do a little bit differently. We're going to ask a question about these two substances. What happens when you put them together? So, baking soda and vinegar. These are two substances, baking soda and vinegar. And when you put them together, it makes three substances. Sodium acetate, which you can find in your food, fizz, the carbon dioxide bubbles, and water. A chemical reaction equation shows you who are the participants, who are the reactants, the things that go together, and then who are the products, the things that are made. Reactants make products. The reactants, and then the arrow points to the products. So we're going to make two substances turn into three substances. And the question is, what's going to happen to the mass, to how much it weighs? So if I take two things and make three, since it's more things, you might predict that it's more mass. Let's find out if that's true or not. So I'm going to take those two substances and turn them into three. So the two substances, I've got a little test tube of vinegar here, and we've got some baking soda in a bottle, and I'm going to put the tube into the bottle, and then I'm going to weigh it to start. So let me get my balance again, and I'm going to put the test tube down into the bottle, but I'm not going to mix the materials quite yet. I'll show you what I'm doing here. I'm just going to put the test tube down in here, drop it in, put the top on nice and tight, so that nothing can get in or out. Hint, hint. Okay, seal that up nice and tight. Put it here on the balance. All right, how much is that? 101. That's the number to remember. So we're taking two substances, turning them into three, and what's going to happen to the mass? If it's more things, is it more mass? I got one more thing and then I start with. Okay, here we go. I'm going to trip it over. I'm going to mix it together. Oh, can you hear that fizzing? See, I got it all closed up so we don't make a big mess all over the lab table. All right, now I'm going to put it back in the balance here. 101? What? It's the same. It didn't change, but wait a minute. I took two things and I made it into three things, and the mass is still the same. Now, how can that be? Well, it has to do with what's really going on. And the reason why we've been looking at how we decode chemical formulas is so that we could solve a problem just like this one. I just wrote the formulas for these substances. This is baking soda, sodium hydrogen carbonate. This is vinegar, acetic acid. And this is sodium acetate, carbon dioxide fizz, and water. Reactants make products. If you were to count up all the atoms of the elements on this side, and if you were to count up all the atoms of the elements on this side, you would find out that they are the exact same number of atoms on both sides. The reason is because in a chemical reaction, all the things that you start with just get rearranged to make the things that you end with. We have a word for that in chemistry, actually three words, the conservation of matter. Conservation means it doesn't go away. The matter doesn't go away, it just gets rearranged. In a chemical reaction, atoms are not created or destroyed. We don't get new elements. It is possible to do that, but in a nuclear reaction, not a chemical reaction. We'll talk about those next semester. In a chemical reaction, all the atoms that I started with, here's sodium over here, there's sodium over there. Here's a hydrogen, and here's four more over here. That makes 5 hydrogens. Here's 3 hydrogens and 2 more over here. That makes 5 hydrogens. Okay, I've got 3 oxygens and 2 more here over here. That makes a bunch. Okay, so all my oxygens are going to add up. I've got 5 over on this side. I've got 2, 4. Here's a 5th one over here. You know, this finger pointing, there's got to be an easier way to keep track of where these atoms are and how they're arranged. So that's what I want to show you today. On the way in, please make sure that you picked up today's assignment, How to Balance Chemical Reaction Equations. I want to show you a little technique, a little trick, a little strategy that I discovered when I was in high school trying to figure out how to make sense of how to balance chemical reaction equations to show the conservation of matter, that all the atoms that you start with are the same atoms that you end up with. When I was taking chemistry in high school, we were just told to use the book to teach ourselves how to do it, and that really wasn't much help. So I want to show you a way that works pretty well for me and has worked for generations of students before you. I think that you'll find it pretty handy and pretty easy and maybe even a little bit fun. But before we do it, just a quick review. This is a chemical formula that we're going to decode. We decoded chemical formulas some time ago. What it shows is a coefficient of 2 and then a chemical formula. This is magnesium citrate. This is something that you might give to babies as a laxative, or maybe not to babies, but older people as a laxative. You take it and things start moving. It contains magnesium, carbon, hydrogen, oxygen. This part right here is citrate, which is part of citric acid, the sour flavor in food. These numbers down here, remember those are called subscripts. We've got parentheses and we've got a subscript outside of the parentheses. And we're just going to quick review how do you decode this formula. When you've got a coefficient there, what we do first is just ignore it. I'm going to cover up that coefficient. I've already listed the elements, magnesium, carbon, hydrogen, and oxygen, and I'm going to count how many there are. Remember that the subscript here counts 3 magnesiums. And now I've got this inside of a parentheses. The 2 outside the parentheses distributes to all the subscripts inside the parentheses. 2 times 6, I've got 12 carbons. 2 times 6, I've got 12 hydrogens. 2 times 7, I have 14 oxygens. Okay, so that's how many are in this formula. But if I have a coefficient of 2, that multiplies everything by 2. So if I multiply this by 2, then I've got twice as much as everything. So I'll have 6, 24, 24, 28. Check my math. Okay, I did it right. What we're going to do today is we're going to work with these coefficients. When you work with chemical formulas, you don't change this part. These subscripts, these parentheses, these element symbols, they all tell you exactly what this material is. That's the formula for the substance. We don't change how we write this because that means that you're changing the substance. We change how many there are. And by changing how many there are, we can get the same number of atoms of each element on both sides of a chemical reaction equation so that we have conservation of matter. Now,